So today I am very happy to be in front of you to present a technical topic on the sanitary landfilling. So we know that how the solid waste management is a big topic and the prime topic nowadays. Every town, every city is facing a lot of problems in collecting, transporting and the disposing the solid waste. As we already know, the public health engineering is a course already studying in the 4th semester. So this is also a part of the public health engineering. So where we used to withdraw the water from source and to supply to the public. Similarly, collecting the wastewater from or used water from public and to be safe disposal to the river streams. Similarly, the dry garbage, so that is usually generated in the municipalities. Of course, from day-to-day activities of a human, lot of solid waste will be generated. There will be a lot of classifications also, biodegradable, non-biodegradable, recyclable. So this is a topic where we are going through a little bit of a landfilling method. So this is one of the disposal method. Let us see. So these are the contents of my presentation. So a little bit brief introduction about the solid waste management and the Indian scenario of the solid waste management system. So little bit details, the classifications, the composition, the collection system, the present collection system, and there are disposal methods, landfilling, leachate, geomembranes as a liner, and some of the advantages. Now let's see, the management of handling the solid waste is nothing but the solid waste management. So this is the discipline associated with the control of generation, storage, collection, transfer, transport, processing and disposal of solid waste in a specific manner. So that is engineered manner in accordance with the best principle of public health, economics, engineering, conservation, aesthetic and other environmental consideration. So not only it's not an easy topic to easily you can say that is a very simple method to collect from door to door collection and throwing off away from the city. We also think that the disposed waste should not harm the environment. So that is one point. Because of this, I am saying that a safe disposal is a very specific manner to dispose the solid waste. So below there is a flow chart. So that is functional elements of the solid waste management. Of course, what I told in the definition itself. So it is represented in a flow chart. So there is a waste generation. Normally the municipalities, households, commercial areas, institutions like that. Later there is a waste handling separation. So I said that there is a biodegradable waste, non-biodegradable waste like that. There is a need of separation, storage and processing. So this all comes in the second step. Next it is a collection. There are two methods. One is transfer and transport. Next separation, processing and transformation. And the last point is disposal. I would like to share the present Indian scenario that there is a report from the Energy and Resources Institute that India generates over 62 million tons of waste in a year. So in 365 days the quantity of generation of solid waste is around 62 million tons. Out of 43 million tons will be collected, 12 million tons being treated before disposal and the remaining 31 million tons simply discarded in the waste yards. So we are focusing on this 31 million tons, how it affects the environment, how it damages the soil, the natural resources like soil, water, etc. In India, solid waste management has been traditionally viewed as a responsibility of course it is a responsibility of every citizen, but it is treated as a responsibility of the local municipal authorities or urban local bodies. However, very few municipality authorities have set up a proper waste processing centers, while even fewer have adequate waste disposal facilities in a place. We already seen, in the early morning, there will be a motor vehicles will come visit your home so that they will collect the solid waste from door to door collection. We are already observing from low local urban bodies to metropolitan cities. So this is how in India the solid waste management topic is considered as. Next point. So this is a classification. The entire solid waste, which is called as a garbage, will be classified as a municipal solid waste. The sources are from households, streets, commercial areas, etc. The second one is industrial solid waste. So definitely this depends upon the type of industries that generates in that locality, and some of the towns will not have any industries at all. So where the industrial waste will be zero. The third one is biomedical waste. We know that it generates from the hospitals, primary health center to multi-specialty hospitals. Next, hazardous waste such as a radioactive waste, chemical, flammable wastes. So these are the main components like where the classifications is done in the solid waste. So this is small picture how the segregation of solid waste is done at the source itself. It's a very simple task when it is done in the source itself, because later it's a very hard task to segregate all the waste when it is collected from entire town. So let us this is little bit in the composition section. When you identify the collected the solid waste, the physical and chemical composition, because there is a necessity to understand the composition of a solid waste so that you can decide which disposal method is suitable for the collected waste. So here specific weight, definitely physical properties, already know that the specific weight, moisture content, particle size distribution, field capacity, permeability of a compacted waste. So these are the physical parameters, so that you can calculate the volume required, calculate the volume of the vehicle requirement, calculate the area of the dumping yard. So these are the parameters which helps you to calculate the identification, the requirements, equipments or requirements of a disposal method. So next is chemical composition. So chemical composition, you can approximate analysis like moisture content, volatile matter, ash, fixed carbon content. Next, fusing point of ash, ultimate analysis of the percentage of carbon, hydrogen, oxygen, nitrogen, sulfur, etc. So these are the some chemicals that may found in the collected solid waste. Of course, the last one is energy value. The combustible organic matter can be converted into energy, so that we can find out the energy of that solid waste in joules or kilojoules. Next one. Now it's a collection system. The first one is a stationary container system and second one is hauled container system, where the containers, the picture itself show you the containers which are situated at prime locations of a household or a colony, where the collected solid waste, door to door collected solid waste will be dumped in a containers. So in one method, the containers will be at the station itself. The name itself indicates that the stationary container system, where the containers will be stayed at the fixed position. The collected solid waste will be transferred to the truck hauling equipment. So second one, where the haul container system, the entire equipment will be lifted on the truck and later it will be carried to a dumping yard. So there is a small difference, so that the environment will not be get disturbed out of the using two methods. Each method will be having its own advantages and disadvantages. So these are the different methods of disposal methods. First one is the open dumping. So this is very general method where sufficient funds are not available from the urban local bodies. The collected waste will be thrown away out of the city where sufficient land is available. Definitely it will cause a lot of nuisance, fly, insects, and it will contaminate the surroundings, of course the groundwater. Second one is landfilling, third one is incineration, fourth one is waste compaction, biogas generation, composting and vermicomposting. So out of all the methods, I am focusing on the sanitary landfilling because I am discussing about the impact and usage of geomembranes in the sanitary landfilling. So here the landfilling, it's an operation in which the waste to be disposed of in a is compacted and covered with a layer of soil. So lot of excavations will be done, earthwork will be done, lot of cells will be made. So of definite size, layer by layer the compacted solid waste will be layered. So over there the thin layer of soil will be covered so as to keep the environment hygienic. At the end of each day operation, when the disposal site has reached its ultimate capacity, that is after all disposal operations have been completed, a layer of 2 feet or more material is applied, as I said, to cover the entire compacted solid waste. Today, sanitary landfill refers to an engineered facility for disposal of solid waste designed and operated to minimize public health and environmental impacts. So this is a section, a typical section of a sanitary landfill site. So you can see below there is a groundwater table. So it is very important to check the depth of groundwater table before excavation, so that the layered solid waste will not comes in contact with the groundwater, so as to keep as a barrier between the groundwater and solid waste. And you can see the small thin layer, green layer, which is a composite liner. Today I am discussing about that liner. So that acts as a barrier for leachate. I will in next slide I will tell you the what is leachate and how it damages the groundwater table. Next. So these are the few terms regarding with the sanitary landfill site. So first one is cell. It is used to describe the volume of material placed in a landfill during one operating period, usually one day. It includes the solid waste deposited and also the daily cover material surrounding it. So there is a small pit of a definite size. Normally it will be in a rectangular shape. The length and width will be provided for, and length and breadth will be same for all the cells in that area. So after excavation, a layer of geomembrane will be placed at the bottom. Later, one day operation. So at one day, how much quantity will be collected in that town? Based on that quantity, the dimensions of the cell will be made. So after filling all the solid waste, a layer of soil will be covered above that so as to keep the hygienic conditions in the surrounding. Second one is daily cover, that usually consists of 6 to 12 inches of a native soil or alternative soil such as a compost that are applied to the working faces of the landfill at the end of each operating period. The purpose of daily cover are to control the blowing of waste material due to wind that happens usually, to prevent the rats, flies and other disease vectors from entering the landfill. So we know that the flies and rats will be sources of spreading the diseases from solid waste to surroundings. So as to keep the rats and flies away from the solid waste, a layer of soil will be placed over the face of the landfill to control the entry of water into the landfill operation. So this happens when the rainy season, the surface runoff will try to enter usually the low lying areas. So this helps you to avoid the surface runoff to enter the solid waste compacted layer. Lift, it is a complete layer of cells over the active area of the landfill. Typically landfill are comprised of a series of lifts. Bench or a terrace, it's a commonly used where the height of the landfill will exceed 50 to 75 feet. Benches are used to maintain the slope stability of the landfill, for the placement of surface water, drainage channel and for the location of landfill gas recovery piping. So after filling the soil layer above the landfill or solid waste, there are chances of gases. As I said, CH2, carbon dioxide, methane gas will be elaborated from the compacted solid waste. So pipe sections will be provided to exclude that gases from the compacted layer. So this is the leachate. It's a highly contaminated liquid with high levels of ammonia, nitrogen, toxic components and limited biodegradability. So when the surface water enters the compacted layer of landfill, it starts to enter the bottom surface of the landfill, where it by carry all the hazardous waste which is present in the solid waste. will be contaminated and reaches the low level area of the surface. If there is no liner, it will start to enter the subsurface area and groundwater. So because of this reason, as I said, it is a very dangerous liquid and it is a limited biodegradability. It contains limited biodegradability. There will be no, degradable organic matter present in that liquid. It is generated from water percolating through a solid waste disposal site, accumulating contaminants and moving into subsurface areas. So this is a typical photo that showing there will be a drainage collection system where the leachate will be collected below the landfill site and it will be carried to the further low level areas. Next one. So this is the commercially available geomembrane layer which is used in every site. You can visit a nearby landfill site to observe these liners. So geomembrane has a very low permeability, that is synthetic membrane liner or barrier used with any geotechnical engineering related material, so on to control fluid migration in a human made project structures or a system. So why do you need geomembranes in a landfill projects? So there are some advantages to use the geomembrane layers. So the membranes will be having a physical and mechanical performance, non-toxicity, long service life, one-time installation. Now you can get the benefits at least 50 to 60 years. The service temperature service range is between minus 700 degree to plus 110 degrees Celsius. It can be used even under the bad conditions. No matter high hills or desert places, the geomembranes can still keep a good performance without cracking. So one of the property of the liner should be its crack resistance. No, under the pressure, if it cracks, definitely the leachate starts to enter the subsurface areas. Corrosion resistance, as we know, there is too much corrosive liquid in the landfill. The geomembranes is not so thick, but it can resist the polluted liquid seepage. So geomembranes plays a heavy role in protecting the earth. Further, the excellent environmental stress cracking resistance property. If you buy a geomembrane made of 100% virgin materials, it can serve up to 60 years. So these are the advantages.